Have you ever wondered what happens when two black holes collide? An intriguing question, isn't it? To understand this, we first need to grasp the concept of black holes. Imagine a region in space where gravity is so powerful that it swallows everything that comes too close. Even light, the fastest traveler in the universe, can't make an escape. This is a black hole, a cosmic entity that continues to baffle and fascinate us. They are the ultimate galactic vacuum cleaners, consuming everything that dares to cross their event horizon, the point of no return. Their existence challenges our understanding of the universe and its laws, making them a subject of intense study and curiosity. Now picture not just one, but two of these cosmic giants. What would happen if their paths crossed? But what happens when these cosmic giants meet? Let's venture into the exciting and somewhat terrifying world of colliding black holes. Imagine two black holes spiraling closer and closer, drawn by each other's immense gravity. It's a cosmic ballet, a dance of two celestial titans bound by the unbreakable chains of gravity. As they twirl in this deadly dance, they inch closer and closer, their gravitational pull growing stronger with each passing moment. But what happens as they draw nearer? Initially, they orbit each other, much like Earth orbits the Sun. But their intense gravitational pull starts to disrupt this dance. The black holes stretch and distort each other, the space around them warping and twisting under the strain of their immense gravity. Then comes the point of no return, the moment when their event horizons, the point beyond which nothing, not even light, can escape, overlap. This is the beginning of the end, the start of the final act. The black holes are now locked in an inescapable gravitational embrace. Their dance becomes a whirl, faster and faster, until they merge in a cataclysmic explosion. This collision results in a larger black hole, but also something equally fascinating: gravitational waves. These are ripples in the fabric of space-time, like the ripples spreading across a pond after a stone has been thrown in. These waves race across the universe at the speed of light, carrying with them the story of the cosmic collision. So in the grand cosmic dance, when two black holes become one, they create ripples across the universe. So we've seen the spectacular collision, but what happens after the crash? In the aftermath, the two black holes, now one, settle into a new stable form. This isn't an instantaneous process. The newly formed black hole is like a giant spinning top that's been knocked askew. It wobbles and shudders, emitting a final few gravitational waves as it gradually stabilizes. These waves are the last whispers of the cataclysmic event that just occurred. This settling process, called ringdown, is a significant event in the cosmos. It's like the universe's own cosmic gong, resonating through the fabric of space-time. The frequency and decay rate of these oscillations can provide valuable information about the nature of gravity and the fundamental properties of space-time itself. In the grand scheme of things, it's a cosmic dance of death and rebirth, with black holes colliding, merging, and settling down into a new existence. And there you have it, the birth, life, and rebirth of black holes in a cosmic collision that's anything but silent. The universe, with its black holes and gravitational waves, is a fascinating place, isn't it? We've journeyed through the mysterious realms of black holes, witnessed their collision and the aftermath. These cosmic events, almost incomprehensible in their scale and power, hold crucial insights into the very fabric of our universe. Studying them isn't just about quenching our curiosity, but it's also about deepening our understanding of reality. So, next time you look up at the night sky, remember the cosmic dance happening far beyond our sight, the dance of colliding black holes.